So again, we continue solving standard linear programming problems using the Simplex method with this example, the clean sweep outlet. And it reads, the clean sweep broom outlet makes two kinds of brooms, push brooms and brush brooms. Their push brooms require 1 hour for forming, 1 hour for bessaming, and a half hour for finishing and are sold for $8. Their brush brooms require a half hour for forming, 3 hours for bessaming, and 2 hours for finishing and sell for $6.50. Each day, the outlet has 45 hours available for forming, 60 hours available for bessaming, and 35 hours available for finishing. Determine how many of each broom the clean sweep broom outlet should make daily to maximize its profit. What is the outlet's maximum profit? So again, the first thing we're going to do is we're going to determine the objective function. And we can see right here, we want to maximize its profit. Right there. So if we want to maximize its profit, we're going to use the variable P. That's what we use for maximizing, P meaning profit. So P is going to be equal to, and if we look here, it's going to depend upon the number of push brooms and the number of brush brooms that are going to be made. Each push broom is $8, and each brush broom is way over here, $6.50. So then we could express the objective function as P is equal to, if we let X be the push brooms, that'll be 8X. And if we let Y be the brush brooms, plus 6.5Y. So this is our objective function for this linear programming problem. So then the next thing we'll do is we're going to build a table that will represent the linear equations. So if we see right here, it says determine how many of each broom. So of course, again, that's going to be our variable, and our variable on our table are going to go across the top. If we let the push brooms be X and the brush brooms be Y, they're going to form these columns. And then for the rows are the items that interact with the variables. And that's the forming, we could see right here, the bessaming, and the finishing. Also in our rows are the totals. And we could see here 45 hours for forming, 60 hours for bessaming, and 35 hours for the finishing. So now that we have all those elements, our table should look something like this. So we can see again, we have our variables across the top here. They create these columns. And then here are our elements here that interact, the forming, the bessaming, and the finishing. Again, we also have our objective function here, the profit, to show the relationship between the dollar amount and the variables. But again, right here, those are the linear equations. So now we could go ahead and we could write those linear equations with slack variables. So we'll do X, that's our 1, plus 0.5Y. Then we put in a slack variable, we'll use U, and that's going to equal to 45. Then we have X plus 3Y plus a slack variable, but the slack variable has got to be different than this equation here, so we'll use V, and that's going to be equal to 60. For the finishing, we have half X plus 2Y plus another slack variable. It's got to be different than the other two, so we'll use W, and that's equal to 35. And then, of course, we're going to put in the objective function, but we have to write it to where all the variables are on one side of the equal sign and zeros on the other. So we'll write this as negative 8X minus 6.5Y plus P, and that's going to be equal to 0. So now that we have all the linear equations here that represent the problem here, we can go ahead and translate this into a simplex tableau. So we'll put in a bracket. Our first column, X, then Y, U, V, W, and P. 1X. Now, the best thing to do is any decimals, we're going to translate them into fractions. It's much easier using fractions. So we'll put in 1/2 y right here. Then we have u. We do not have a select variable v or a select variable w or a variable p. So now we can put in our vertical line and 45. Then 1, 3, no select variable u. Then 1, 0, 0, and 60. Again, we're going to change this into a fraction. So that'll be 1/2, 2, 0, 0, 1, 0, then 35. Then we'll put in -8. We're going to change this into a fraction. -6.5, that's going to be -13/2. Then 0, 0, 0, 1, and 0. Put in our horizontal line. And then we'll close off that bracket. Notice our diagonal here. These are our basic values here. These are the values that we're going to change. So then the next thing we're going to do is we're going to determine our pivot element. So again, to be able to select a pivot element, we look for the most negative value in the last row here, and that's going to be -8. So this column becomes our pivot column. Then our pivot row, we take each value within that pivot column and divide it into the constants over here. So 45 divided by 1, that's 45. 60 divided by 1, that's 60. And 35 divided by 1/2 is 70. So the row that yields the smallest ratio is our pivot row, and it's going to be this row right here and this column right here. So our pivot element is going to be the 1 right at the top up here. So now that we have that, we go ahead and we'll use our elementary row operations to go ahead and then start changing the other values here into zeros to make this into a unit column. So we'll take row 2 and we'll subtract out row 1. Put in our bracket. 1 minus 1, that's 0. 3 minus 1/2, that's 5/2. 0 minus 1, that's -1. This stays 1, 0, 0. Bring down our vertical line. 60 minus 45 is 15. Close off our bracket, and we fill in the rest. So now we can target this element here. So that'll be row 3 minus 1/2 of row 1. So we'll put in our bracket over here. 1 times 1/2 is 1/2. 1/2 minus 1/2, 0. The whole idea, right? 1/2 times 1/2, that's 1/4. 2 minus 1/4, that's 7/4, keeping everything as fractions. 1 times 1/2 is 1/2. 0 minus 1/2, that's a -1/2. 0, 0, and 0. 0, 0, and bring down the 1. And the other 0. Put it in our vertical line. 45 times 1/2, that's 45/2, and 35 minus 45/2, that's 25/2. Close off our bracket, and of course, then we fill in the rest. Carefully put in our horizontal line. So now we can target the last element here. So we'll do row 4 plus 8 times row 1. Put in our bracket. 1 times 8 is 8. Negative 8 plus 8, 0. 1/2 times 8 is 4. Negative 13 halves plus 4, that's negative 5 halves. 1 times 8 is 8. 0 plus 8, that's 8. 0, 0, and 0. 0, 0, and 0. 0, 0, and then 1. Bring down our vertical bar. 45 times 8, that's 360. And 0 plus 360 is 360. Close off the matrix, and we can fill in the rest. Put in our horizontal line. And now we've changed this into a unit column. So then step 3 says we're going to check to see if there's any negative values, and there is one right here. So then we'll go ahead and determine our next pivot element from this pivot column right here. So from our pivot column here, we'll take 45 divided by 1/2, that's 90. 15 divided by 5 halves, that's 6. And 25 halves divided by 7/4, that's approximately 7.1. So this is going to be our pivot row, and this is our pivot column. So our pivot element is going to be 5 halves. So we'll start there. So then we'll start with 2/5 of row 2. Put in our bracket. 0 times 2/5, that's 0. 5 halves times 2/5, that's 1. That's the whole idea. Negative 1 times 2/5, that's negative 2/5. 1 times 2/5, 2/5. 0, 0. Bring down our vertical line. 15 times 2/5, again, is 6. Close off our bracket, and we fill in the rest. Put in our horizontal line here. So now we could target either one of these. We'll go ahead and we'll target this one up here. So we could say row 1 minus 1/2 of row 2. Put in our bracket. 0 times 1/2 is 0, so we leave our 1. 1 times 1/2 is 1/2. 1/2 minus 1/2, there's our 0. Negative 2/5 times 1/2, that's negative 2/10. 1 minus negative 2/10, or in other words, 1 plus 2/10, is 6/5. 2/5 times 1/2, that's 2/10. 0 minus 2/10 is negative 1/5. 0, 0, and 0. 0, 0, and 0. Bring down our vertical line. 6 times 1/2 is 3, and 45 minus 3 is 42. Close off our bracket and fill in the rest. Put in our horizontal bar. And now we can continue with this one. So we will take row 3 minus 7/4 of row 2. And we continue. 0 times 7/4 is 0, and of course we have 0. 1 times 7/4 is 7/4. 7/4 minus 7/4, 0. That's the whole idea. Negative 2/5 times 7/4, that's 7/10. Negative 1/2 minus negative 7/10, or in other words, negative 1/2 plus 7/10, that's 1/5. 2/5 times 7/4, again, that's 7/10. 0 minus 7/10, that's negative 7/10. 0, 0, and 1. 0, 0, and 0. Bring down the vertical line. 6 times 7/4, that's 21 halves. And 25 halves minus 21 halves is 2. Close off our bracket and fill in the rest. Put in our horizontal line. And now we target this element. So we could take row 4 plus 5 halves of row 2. 0, 0, and 0. 1 times 5 halves is 5 halves. Negative 5 halves plus 5 halves, that's 0. That's the whole idea. Negative 2/5 times 5 halves, that's negative 1. And 8 plus negative 1, that's 7. 2/5 times 5 halves, that's 1. 0 plus 1 is 1. 0, 0, and 0. 0, 0, we bring down the 1. Bring down our vertical line. 6 times 5 halves, that's 15. And 360 plus 15, that's 375. Close off the bracket, and we fill in the rest. Put in our horizontal line. So now we change this into our unit column. Step 3 then says we check to see if there's any negative values. So there are no negative values left in the last row here. So we're done. So recall that our objective function was p is equal to 8x plus 6.5y. So it says determine how many of each broom the clean sweep broom outlet should make daily to maximize its profit. And then what is the outlet's maximum profit? So as we can see right here, that's x, and x was our push brooms. So x is equal to 42. And y, that was our brush brooms. So y has got to be equal to 6. So the clean sweep outlet should make 42 push brooms and 6 brush brooms, and that would come out to have a maximum profit of 8 times 42 plus 6.5 times 6. And of course, this is in dollars. It's going to come out to be $375, which is what we determined right here. So there we go.